G'day everyone, let me show you how to use frequency separation to retouch your image in Photoshop. My name is Hoy, and in this video, I'll show you how to use the frequency separation technique to produce high-level, non-destructive retouching that you can apply to portraits, landscapes, products, and more. This video isn't about blindly copying which sliders to move or buttons to press. I'll not only explain what the technique is, but also how it works behind the scenes. So by the end of this video, you'll know more than most of the tutorials out there and be the envy of your family and friends. So if you want to follow along, you can use the exact images that I'm using. The links are in the description. Before we do any retouching, I want to make sure that we all understand what exactly is frequency separation, because the first time I heard about it, it almost turned me off because it sounded like the least Photoshoppy term I ever heard. If you already know what it is and how it works behind the scenes, including why we use the add, subtract, and linear light blend modes, you can see the timestamps below to jump straight to the section where I show you how to retouch your image non-destructively. Okay, so to understand what frequency separation is, we need to know a little bit about how images are stored, like how computers process digital files, because it's a little bit different to how we see them in the real world. So to help me explain this, I prepared to explain a file which I'll keep coming back to as we go along. I'm going to turn this layer off and then turn on my next layer. Now, some of us probably already know that digital images are made out of pixels. So if I zoom into this picture here by pressing Option on my keyboard and scroll wheel mouse up, you can start to see these little squares. And these little squares are called pixels. And when you have lots of them, in the millions of them, we can see that it eventually makes up the picture. We don't usually see the pixelation because the normal human sight can't pick up these little dots at a distance. I'm going to fit it to screen again by pressing Command or Control 0 so we can see the whole image again. Now, just because that's how we see the image, that's not necessarily how computers store the information, because the file would be way too big if computers were to store each and every pixel. Now let's take the case of a full high-definition picture which you see in front of you here. Now a high-definition picture has 1920 pixels across and 1080 pixels down. And that will give you a total resolution of just over 2 million pixels. Now, if you wondered how that calculation was done, it's simply the number of pixels wide times the number of pixels high. Now, the computer doesn't store 2 million pixels. What it stores is a representation of those pixels, and it only keeps the important info and discards a lot of them while it tries to maintain a balance of quality. So then the next question is, how do they store and process the information? So again, to aid our understanding of that, I'm going to turn off this layer and then turn on this layer. Now remember, what we're talking about here is frequency separation, and that is literally separating the frequencies. But then you might say, well, yeah, but what does that mean? Well, most of us probably have seen this sine wave here, which we normally associate with audio. But with images, this wave is not what we're talking about. When we're talking about images, we're talking about spatial frequencies. So in a 2D image, that means it's got an x-axis and a y-axis. And the frequency doesn't look like this wavy curve here for an image. Instead, the frequencies are represented by black and white shades, as you can see here. I've got some blocks here, which represents the building blocks of an image. Now imagine millions of these combined together to give you whatever image you want. So the detail of an image comes from areas with high contrast. That's where the high frequency sits. And where there is less contrast, that's where the color and tone is. And that's where there is low frequency. And so by separating this high contrast and low contrast, this is what we mean by frequency separation for an image. Now, to cement that knowledge in a little bit more, I'm going to show you a fun image that was created by Dr. Aude Olivia from the MIT University in the US. I'm going to switch this layer off and then turn this layer on. And this is popularly known as the Marilyn Einstein photo. At this distance, you probably see the image of Albert Einstein. But if I start to zoom out by pressing Command minus on my keyboard, you probably start to see another person, and that is Marilyn Monroe. Isn't that crazy? Now let's zoom back in and fit it to screen by pressing Command or Control 0. Now the reason for this illusion is basically the picture is made from two layers. One of the layers contains the high frequency, the detail, and that's the layer with Albert Einstein on it. That's the layer with the highest contrast. And the blurred layer, if I zoom back out again, is simply made out of low contrast. That's the low spatial frequencies. Now I'm going to fit it back to screen by pressing Command or Control 0. And now let's relate what we've learned so far back to frequency separation in Photoshop. I'm going to turn off this layer and then turn on my next layer. Now frequency separation in Photoshop means that we'll start off with the original layer here, and then we'll make two other layers. The top layer will have all the detail here, and then the bottom layer will only contain the color or tones, and that's the low spatial frequency. So I'm going to zoom in a little bit more so you can see what we're talking about here. It's originally black and white. I did not do any color processing. It's got the detail plus the tones here. If I scroll down by pressing spacebar on my keyboard and just dragging my mouse down, and here you'll see the detail. So you can probably see it more pronounced on his jacket here. I'm just going to zoom in a little bit more so you can see it. So this doesn't contain any of the color or the tones. In any case, this is a black and white image, so you won't see the color anyway, but you won't see the tones here. You only see areas of high contrast, which depicts the detail here. So I'm going to zoom out a little bit by pressing Option or Alt on my keyboard and scroll with mouse down. I'm going to pan down to the low frequency layer or the blur layer, and I'm going to zoom back in here, and you can see that there is no sharp lines here. All it has is the information of the tones. So I'm going to fit it to screen again by pressing Command or Control 0. And let me explain what this side of the image is saying. So what I'm trying to explain here is that if you stack the detail or the high frequency layer on top of the blur or the low frequency layer together, you should end up with your original sharp image here. So the next question you might have then is, well, why do we go to all that trouble? Why do we need to separate the two? Well, the answer is by having the detail on one layer and the color or tone on the other layer, we can adjust one layer without affecting the other. So in other words, we can affect the texture or the detail of someone's face or hair or jacket without touching the color of it, and vice versa. Now, I've used a portrait as an example here, but you can apply frequency separation to any image that you want to separate the detail or the color and tones. That could be a portrait, a landscape, or product photos, or anything else. Okay, so now that we have a little more understanding of what frequency separation is about and why we want to use it, let's start our actual frequency separation. We're going to use two images in our example. The first one we'll use is an 8-bit image, and the second one is a 16-bit image. The links to both of them are in the description. Given this tutorial is about frequency separation, I won't go into too much detail about the difference between an 8-bit image compared to a 16-bit image. All we need to know at this point is that the 16-bit image can display more colors than the 8-bit image. So once you've downloaded, let's go to File, Open, navigate to the folder where you've got your image saved, click on the girl file and press Open. Okay, so remember for frequency separation, we need to create two layers. The first layer containing the detail, which is the high frequency, and then the second layer containing the color or the tone. So to duplicate this image, let's press Command or Control J twice on the keyboard. And let's rename this top layer by double clicking on the words to detail. And just so we can burn the concept into our minds, I'm going to type in high FQ for high frequency. I'm going to press Tab on my keyboard to jump to the next layer and then rename this to color bracket low FQ for low frequency and press return on our keyboards. Okay, so the next step is to turn off the detail high frequency layer, and we're going to work on this color low frequency layer. Now remember, what we want from this layer is simply the color and tone, and we can do that by removing all the detail. In other words, we can blur this image to the point where we only have the colors or the tones. So let's go to Filter, Blur, and we're going to use Gaussian Blur. I'm going to reset this so we can start from the beginning. Just make sure that you've got preview checked, and I'm going to use my cursor here and click on this little scar here just so we can have a focal point in this little preview screen here. And all I'm going to do is just click and drag this to a point where I start losing the detail. So this is a little bit of an experimentation. So what I'm looking at here is the image on the left here where I'm asking myself, well, do I see any more detail? If I want more of a bigger zoom, then I can press this magnifying glass here, and this has got no detail whatsoever. So at least in this area, this little scar here, this looks fine. But let's check some other areas. You can see that the cursor has changed into a hand. When it does, I can click and drag to an area that I want to compare it with. And this also looks like it has lost the detail in it. I can confirm that by pressing on this magnifying glass here, click and drag to move across. And the blur might be a little bit too much, so I'm just going to dial it down. And you don't want to overdo it. Otherwise, when you retouch your image, what you'll see is too much blur to the point where you might see halos. So the guidance here is only go to the point where you lose the detail, and 4.7 looks good to me. I'm going to press OK. And now we're going to work on the detail high frequency layer. Let's turn on the visibility by pressing this icon here. And let's just make sure that the layer is selected by pressing on the layer. And what we're going to do is apply something called apply image. When I first heard of that, it didn't make any sense at all, but you can follow me and I'll explain as we go. So to apply the image, we go to image and apply image. I'm going to reset this to the default, which I think is normal. So before we walk through all these options here, let's just talk about what is apply image in the first place. What this does is asking what effect you want to put onto the file. And once you've selected all these options here, it'll use the luminosity of the layers you've chosen and then apply that change there. So I know that might have sounded way too complicated. So let's go through these options one by one. So the source is simply asking you what file are we starting off with. This is just the image that we've got here. And layer just means which layer do you want to apply the effect with. Now, because we have 3 different layers, it gives us 3 different options. Now remember, frequency separation is about having the detail on this layer here and then the color or tone on this layer. Now at the moment, the detail layer has all the information, the detail and the color. So just to get the detail on this layer, all we need to do is subtract the contents of this color layer here, and then what we're left with is the detail. So the layer that we want to blend with is color. So far we're using the girl JPEG file. We're going to do something with this color layer here. And then it's asking, well, what channel do you want to use? And it's given us a few options: red, green, blue, transparency. Red, green, and blue are the standard channels that makes up an image in the RGB mode. I won't go too in depth with this. I do have other videos to explain what the color modes are about, which I will link down below. But for now, we'll use the luminosity of all these channels here, which is the RGB channel. Let's make sure that we have inverted not selected, and then the blending mode is probably the most important here. So at the moment it's normal, and if I click on the options here, some of them are quite funky. So in this area we have darken blend modes, and these will lighten it, and these will add contrast. And here we've got something called add and subtract. And we won't go through these, what we're interested in is subtract. And let's just remind ourselves why we need to use subtract. Remember, the goal here is to make this layer only have the detail in it. And to only get the detail from it, we start off with the original image here, and then we subtract the color or the tone or the low frequencies. So then we're left with just the detail. So I'm going to go back to this option here and select subtract. Now by subtracting, I get these two options here. I'm going to reset this to default, which I think it's 1 and an offset of 0. Now let's just walk through the effect of all the options that we've chosen so far. We'll start off with source. This is the file that we'll start off with. It's going to take the luminance value of this layer here. Let's make up a hypothetical example. Say the luminance value of a pixel in this image is 200. Now the luminance value goes from 0 to 255, 0 being black and 255 being white. Then it will take the luminance value of this layer. Hypothetically, let's assign that as 100. So what Photoshop is doing at this point is taking the luminance here, 200, minus the luminance of the color value, which is 100, that leaves 100. Then it divides it by the scale. So 100 divided by 1 is 100. Now the range of the scale is between 1 and 2. If I input a figure more than 1 but equal to or less than 2, the image will get darker. Now this picture is already quite dark, so I can't demonstrate it with these settings. So I'm just going to increase the offset just so you can see it a little bit better. And now if I change this 1 to 2, the image has lost some of the detail here. And that's because some of the detail has got a little bit darker. And we know that to be mathematically true because if we do the maths again, we have the luminance value of this file being 200 minus the luminance value of the color layer, which in our hypothetical example, I've assigned it to 100. So we're left with 100 divided by 2 is 50. Now 50 on a scale of 0 to 255 is a lot closer to 0, which is black, than 100. That's why when you have the scale more than 1, the image will get darker. Now what offset is that it will adjust the overall luminance based on this value here. So the offset has a range of 0 to 255. So if I have an offset of 128, it's 50% gray, which is smack bang in the middle. Now I'll explain a little bit more why we use the scale of 2 and the offset of 128 later. For the time being, let's press OK. And now we're left with this gray image here, which if we go back to my explainer file here, I did mention that by combining the detail layer here, which we've got the gray layer here, with the color or blur layer, the low frequency layer here, we should get the original layer. But we're not seeing that. We're only seeing this layer here. So what we need to do is to change the blend mode from normal to linear light. Now let's just check that the combination of the detail high frequency layer plus the color low frequency layer is the same as my original layer here. Now I can do that by grouping these two layers. I've already got this layer selected, so I'm going to press Shift on my keyboard and click once on my mouse. Let's press Command or Control G to group this. I'm going to double click on this and rename this to FS for frequency separated. Let's press return on our keyboard, and I'm going to turn off the visibility of the FS layer. So I'm going to turn it off, on, and hopefully you haven't noticed any difference, and that is the point of the frequency separation. Now the difference is now that we have the detail layer and the color separate, we can work on each of the layers individually while not affecting the other layer. Before we apply the frequency separation settings for a 16-bit image, let's just explain why we need to set the scale to 2 and the offset as 128, and why we needed to set this as linear light. I'm going to come back to my explainer file here. I'm going to turn this visibility off, and I'm going to turn this on. And this is probably more scary than the other dialog box. But again, don't worry, I'm going to walk you through it step by step. Now, this is the formula that I described as we were walking through it. So this is the luminance layer of your original layer here. And this is the luminance of your color layer divided by 2, which is the scale, plus your offset factor. The offset factor isn't 128 here. The 128 is the offset value. You can think of the offset factor as a percentage, where the maximum range is 255, and that's a factor of 1 or 100%, and the minimum value of 0, which is black, of having a 0 factor or 0%. So if we substitute this in, we'll have the luminance value of the original file minus the luminance value of the color layer divided by 2, which is our input here, plus the offset factor of 0.5. 128 divided by 256 equals 0.5, and that's the offset factor. Now, the formula for linear light is 2 times the luminosity of the detail layer, which is A, plus the luminosity of the B layer, which is the color layer here, minus 1. Now, for the next bit, let's put on our thinking caps on because it does involve a little bit of algebra. I'm going to grab my pen so I can make some squiggles on top of this. So I'm going to create a new layer to make my scribbles on. I'm going to press B on my keyboard to invoke the brush tool. I'm just going to resize that a little bit smaller and then increase the hardness. Let's change the color to something like red so you can see my writing. Now, this is the formula for linear light, which I've duplicated here. Now, remember, A is this here. So I can substitute what A is here. And remember, B is simply the color. So I can substitute B for color and then minus 1. So if I rewrite that again, that's A here and that's B here, giving me back my formula for linear light. I'm just going to delete all the scribbles so you can see it a bit better. Command or Control A on my keyboard, and I'm going to press delete and then just deselect that by pressing Command or Control D. The next step is to expand this out. This is divided by 2, so to get this as a whole number, you multiply this by 2. That means I need to multiply the half by 2. When I expand that out, this will disappear. The divided by 2 will disappear. This will disappear here. And then 2 times 0.5 equals 1. So what we're left with is the original image minus the color plus the 1 here. And then this is the B minus 1 here. So plus color minus 1. Minus color plus 1 cancels itself out. Another way of saying that is plus color minus color equals nothing. And then 1 minus 1 cancels itself out. So then what we're left with is the original image. So what we've done here is mathematically proven why we needed to use these settings. Now, that doesn't mean that the linear light has any magical properties to it. It just so happens that the equation for linear light helps us get back to the original image when we combine these two layers together. I'm going to clear all this out by pressing Command or Control A on my keyboard. I'm going to press Delete to remove all the scribbles and then press Command D or Control D on my keyboard to deselect that. And now what we're going to do is do the same process but for a 16-bit image. And we need to do that because it has a different settings that we need to apply here. And remember, all a 16-bit images is basically an image that contains more colors than an 8-bit image. The link to the 16-bit image is in the description. So after you downloaded it, let's open it by pressing Command or Control O. Select your image, which is the NEF file. That stands for Nikon Electronic Format, which is Nikon's proprietary format, and then press Open. Now, it doesn't open straight away in Photoshop. It actually opens up in Camera Raw. I won't go through what Camera Raw is because we won't be making any adjustments to this. What we want to quickly check is that this picture is indeed a 16-bit image. Now, if I go down to this area here, it does confirm that it is 16 bits here. And then let's press open. Now I can also check the bit depth of this image by going up to this window tab here, and this says 16, which means that it's a 16-bit per channel image. Now for the 16-bit process, I will go a little bit quicker, but don't worry, I will go over what I'm doing. Now remember, we have to duplicate this layer here twice by pressing Command or Control J twice. Let's rename this layer. Let's turn off the visibility of this layer and let's make this layer blurred. So make sure that you have this layer selected. Let's go to Filter, Blur, Gaussian Blur. And again, I'm going to click on this little mark here and I'm going to reset it to 0. And I'm just going to slide it to a point where I don't see any more detail. So something like this. I'm going to zoom out a little bit. So what you'll see with the 16-bit image, the blur that we need to use tends to be a little bit higher. We'll make it 10.1 and then press OK. Let's turn on the visibility of this layer and make sure that detail is selected. Let's go to Image and apply Image. Now, as you can see, it's inherited the settings of the previous exercise that we did. We won't worry about that for the time being. Let's go back up to source. We only have one option, so we'll click on that. The layer that we want to use is color, and the channel that we want to use is RGB, which is all the channels available. And for last time, we left the invert unchecked. Here, we need to check it. For the blending mode, you can see that last time we used subtract. Here we'll use add. We'll use a scale of 2 and an offset of 0. Again, I'll explain exactly why we need to use it mathematically after I press OK. Let's change the blend mode from normal to linear light. And again, let's check that the combination of this layer here with the color layer equals the original layer here. So with the detail layer selected, I'm going to press Shift on my keyboard and click on the color layer. I'm going to press Command or Control G on my keyboard. I'm going to double click on the group 1 label and I'm going to rename this to FS for frequency separation. Let's press Return on our keyboard to accept that change. Now I'm going to zoom in a little bit by pressing Option or Alt on my keyboard and scroll wheel mouse up so we can see the image a little bit better. And I'm going to turn off the visibility of the newly created frequency separated layers. So this is off and this is on, off, on. And hopefully there are no changes. And remember, that's the point of frequency separation, separating the detail and the color or the tone so we can work on each of the layers separately, but then the combination of the two will add back up to the original image. I'm going to fit it to screen by pressing Command or Control 0 on my keyboard. And let's explain why we use the settings that we just did. I'm going to refer back to my explanation file here. And again, we'll start off with the formula of the blend mode that we're using. In this case is add. Now, the add formula is different to the subtract formula. The subtract formula was original minus the color. Here we've got the original plus 1 minus the color. So why are we doing 1 minus the color? Well, because we've selected invert here. And to calculate the inversion of the color layer, you have to go 1 minus the color layer. And the reason why this isn't minus as it was for the subtract formula is because we're adding it here per the blend mode here. So after we have original plus 1 minus the color, we again divide it by the scale and then plus the offset factor. Now remember, it's the offset factor, which is any number between 0 and 1, and not the offset value, which is 0 to 255. In this case, the offset factor or the offset value will both be equal to 0 because here we put it to 0 anyway. So what we're left with is the luminance value of the original file plus 1 minus the luminance value of the color layer, and we do 1 minus because we're inverting it, divided by the scale of 2 here. Now again, that by itself doesn't explain why we've used these settings here. We need to combine that with the linear light blend mode. And the formula for the linear light is the same as the 8-bit process because that doesn't change. And the formula is 2 times the luminosity of this layer here, the A layer here, plus the luminosity of this layer minus 1. So if I substitute that with the values here, I get this whole chunk here. Now the colors corresponding with what I'm substituting with. So this whole block of orange is representing A here. The next step is plus B, which is the color here, and then minus 1, which is simply the formula. I'm going to grab my pen again by pressing B on my keyboard to invoke the brush tool. Going to select this top layer here. Again, what we need to do is to expand this out. Because this is divided by 2, I need to times it by 2. I need to times the 0 by 2. And that will make the leading 2 disappear. In the middle, we'll just be left with original plus 1 minus the color. And then here, 2 times 0, well, anything times 0 is 0 anyway. So the 2A then is simply original plus 1 minus color. And then this bit here plus color minus 1 is simply this bit. Again, 1 minus 1 will cancel itself out. Minus color plus the color, or another way to think about it is color minus color will cancel itself out. And now we're left with the original image here. Again, the linear light blend mode isn't a magical blend mode. It just so happens that its formula brings our image back to the original. But then you might ask, well, why couldn't we just use the same setting as the 8-bit image? You promised me that, but you still haven't answered it. I wanted to walk you through the mathematical calculations first before I answered it. I wasn't ignoring it. To answer that, I'm going to clear this out. I'm going to turn the visibility of this layer here and then turn on the last layer. This is the last explanation layer that I'll go through. Aren't you glad? So the question here is, why couldn't we use the same settings on the 16-bit image compared to the 8-bit image? Well, the short answer is that in Photoshop, the pixel range for a 16-bit image isn't really 16-bit. What do you mean? I can hear you ask. Yes, it's true. So to calculate the pixel range of an 8-bit image, the formula is 2 to the power of 8. 8 for the 8 bits, which gives you 256. And that gives you a pixel value between 0 and 255. Now for a 16-bit image, it isn't 2 to the power of 16, where 16 represents the 16 bits. Instead, what Photoshop uses is 2 to the power of 15 plus 1. Now 2 to the power of 15 is 32,768. Plus 1 is 32,769. Now, just as a comparison, the pixel range of a 16-bit image is 65,536. Now, why is there a difference? Well, the explanation that I can find is that it gives a midpoint that is useful for blending, and it also enables faster calculation. Now, if you feel a little bit cheated about that, well, both images, either the 8-bit or the 16-bit apply image settings, are not theoretically 100% accurate anyway, because Photoshop applies some rounding, some unexplained rounding when it performs the calculations when we apply image. The settings that we use in apply image merely reduces the measurement errors such to the point where it's not noticeable. So don't feel cheated. It's the best we can do in Photoshop. If you made it this far, I congratulate you very much, because it's not easy to understand the details behind what frequency is doing. Now let's do the exciting bit, which is actually the frequency separation retouching. And because you've stuck around, I'm going to show you how to retouch an image non-destructively. So we'll be using the 16-bit image to retouch. Let's go back to it here. Now, before we retouch the image, I just want to explain my general approach to retouching. Now, there are no right or wrongs, it's just some principles that I apply myself. Now, my general approach is only change things that are temporary, like things that would be gone in, say, 6 to 12 months. That could include pimples, cold sores, etc. Anything permanent like a birthmark, a mole, or even a person's skin color, I would generally leave it alone because that makes up the person's character, I believe. That's who they are. But obviously, if you know who the person in the image is and they specifically asked you to change something, then you have their permission to do so. And then it will be up to you to see whether you're comfortable to do that or not. So with that caveat out the way, let's just have a quick look at what we're going to retouch here. I'm going to zoom in a little bit by pressing Option on my keyboard and scroll wheel mouse up. You can see that the model's face has got very good skin to begin with, so there's not a lot of retouching to do, but the techniques that I will show you will work regardless of how much blemishes the person have or how little they have. So don't feel like you're getting ripped off by me using a picture with a model that has minimal blemishes. So I'm going to mark out the areas where I'm going to retouch so I don't forget it. I'm going to make a new layer here by pressing this layer here. I'm just going to move this out of this group here. Let's bring up our brush tool by pressing B on our keyboard. And let's just start circling the areas that we're going to fix. Now you can obviously keep going as much as you like, but for this tutorial, I think this will do. I'm going to fit it to screen by pressing Command or Control 0. And now with the areas marked out, I have a good idea of what I need to do now. I'm going to turn off this scribble layer here. I'm just going to select this detail layer here. Now most tutorial up to this point will tell you to simply work directly on this layer, but my general approach to editing or adjusting images is to work non-destructively. So I don't want to work on this layer. I want to work on another layer. So I'm going to press Command or Control J to duplicate that layer, and I'm going to clip it by moving my mouse between the layers and press Option on my keyboard so this arrow and square shows up. And once it does, let's click once on our mouse and this will clip it. Let's change the blend mode from linear light to normal, and that will bring us back to the original image here. And what we need to do now is use our clone stamp tool by going here on our menu layer, or you can press S on your keyboard, and let's switch off this layer as well as the background layer. Now in this view, you might just be able to see the texture here, but it's a bit hard to see. So we need to do something to increase the visibility of that. So what we'll do is create a solar curve. So with this layer selected, the clip layer selected, let's go to our adjustment layer and go up to curves. I'm going to resize my properties panel here so I can see the graph. And what I'm going to do is just going to click and drag up here. And then beside it, do another point, but in the opposite direction, just click and drag down and then up again and then down again. Now, if I move this side to side, it'll get darker or brighter. So something like this, I'm going to increase the apex of that. I'm going to move this down a bit and just adjust it side to side while keeping an eye out on this image here and adjust it to a setting where you can see the texture a bit more. Now I'm going to just resize my layers panel again, and I'm going to select the detailed layer, the clip one, not this one, and I'm just going to turn on my layer 1, which contains my scribbles, just to remind myself where I need to fix. And I'm going to zoom in by pressing Option on my keyboard and scroll wheel mouse up. And now that I'm in this view, I don't need my layer 1 to show me where I need to fix now, so I'm going to turn that visibility layer off. And you can start to see the areas where you need to change. An opacity of 100, let's turn down our flow to something like 15, 14 even. And what flow is basically the strength of your brush. So with the low flow, the effect that we're going to do will be not as much. So it will take a few goes off the brush to really apply the effect. Now I've got my brush here, and what I want to do is to have a brush size just slightly bigger than the area that I'm going to retouch. If you need to resize your brush, you can press Control Option left click and then drag your mouse to the left to make it smaller, or Control Option left click and drag your mouse to the right to make your brush bigger. With all those buttons pressed, you can go up to increase the softness or down to increase the hardness. If you're on a PC, that's Alt, right click and drag your mouse to the left to resize it smaller, drag it to the right to resize it bigger, up to increase the softness, and then down to increase the hardness. So we want a smallish brush, just enough to cover the blemish area, and then a soft brush. I'm going to choose a 0% hardness all the way up here. Now with your brush size and your brush hardness set, let's make sure that our sample area is selected as current only. You only want to sample this area and not anything below it. I'm going to take a sample somewhere here by pressing Option on my keyboard. That's Alt if you're on a PC. What you want to do is to clone an area close to the area that you're going to retouch, and then just press once on your mouse and that will sample that area. I'm going to go over the area that I want to paint out and then just slowly paint it in. And there you see that the texture has replicated wherever I've sampled. Now I'm going to do the same for this area here. I'm going to press Option on my keyboard, that's Alt if you're on a PC, to sample it. Click once and then start to brush that out. Now with a flow of 14%, I needed to brush it multiple times. But the reason why I didn't go to float 100, because I don't want the whole effect to simply abruptly appear. Now let's do one more together and I'll see you back when we're ready to do the color layer, the low frequency layer. So let's move up here where you can see a dimple here. I'm going to sample somewhere here. I'm going to press Option or Alt on my keyboard, click once on my mouse and then just paint that in here. Now here you see that the texture is kind of running from right to left, and what you want to do is to follow the direction of it. Otherwise you'll have texture that's running against the natural texture of her skin. Now that we've finished touching up the detailed layer, I'm going to turn off the solar curve here and I'm going to turn on my color layer here just to see the before and after. I'm going to zoom in again by pressing Option on my keyboard and scroll wheel mouse up, and I'm going to turn this visibility off and on. So you can see just by changing the texture, some of the blemishes on her skin has been removed, but there are still differences in color here. So the next step is to adjust the color so the color of the blemishes blends in with the model's skin. So I'm going to turn off the detailed layers here. I'm going to click on this color layer here. Let's make a new layer by pressing this layer icon here. Now let's change our tool from the clone stamp tool to the mixer brush tool. So this is your brush icon here. So what we need to do is press and hold on your mouse until these options fly out and select the mixer brush tool here. And you can think of a mixer brush tool as a wet paintbrush. So that explains the wetness here. So if you have 100% wet brush, so it has a lot of smudging effect. If the wet is set down to 0, you basically have a dry brush. And if you can imagine, a dry brush in the real world will not smudge as much as a wet brush. We're going to change that to 100%. Our load is 100%. And what the load is how much color the brush can take at one time. Now for the mix, you might have it at 100% or any other figure. For the settings that we're going to choose, it doesn't matter. So don't worry about the settings here. Now what the mix is how much of your chosen color, here I've got it red, do you want to blend with this color here, the background color. A mix of 0 means that you'll take 100% of this color. So if I demonstrate that by moving on this scribble layer here, and then just brush this on, you can see the effect of the red coming out here. If I go all the way to 100, it means that I'm using 100% of the background color, so none of the red comes out. In any case, we're not going to use this setting because we're going to set this, whatever color you have, to a clean brush. And then we're going to unselect this one, load the brush after each stroke. So by doing that, it negates whatever figure you have here anyway. Now the flow is what I mentioned before, is basically how much ink do you want to come out of the brush. And you can leave the smoothness to 0, and that just means that how much smoothness you want Photoshop to make with your hand-drawn brush strokes. So by putting it to 0, you're saying just take my brush stroke as it is. Whether squiggly or not, don't make any adjustments to it. We'll leave this airbrush icon turned off and make sure that we have sample all layers checked, and this is really important, as well as making sure that the solar curve as well as these layers, the detail layers, both of them are turned off, because it will make a weird effect if you have any other layers other than this layer 2 and the color layer turned on. Now while we're here, let's double click this so we can rename it to color adjustment and press return on our keyboard. Now the final setting that I didn't go through is this one here, which is clean the brush after each stroke. Now because we've got a transparent selection here anyway, it doesn't really matter what we pick. I'm going to turn off my scribble layer by pressing this visibility eyeball here. I'm going to make sure that my color adjustment layer is selected. Let's zoom in a bit so we can see a little bit better by pressing Option on the keyboard and scroll wheel mouse up. And the final thing to do is just to make sure that you've got an appropriately sized brush. If you need to resize it, the keyboard controls are Control, Option, left click on your mouse, and then just drag it to the left to make it smaller, and then drag it to the right to make it bigger. If you're on a PC, that's Alt on your keyboard, and then right click on your mouse, and then drag it to the left to make it smaller, drag it to the right to make it bigger. Now because we want a soft brush with all those keys selected and my mouse, I'm going to scroll up so my hardness is 0. If you want your hardness to be increased, you can drag it down. But as I say, I want it to 0, so I'm just going to slide it back up again and then just decrease the size of my brush. And the brush strokes that I'm going to make is a soft, subtle one in small movements. I don't want to make big exaggerated movements because that will color the area of my exaggerated motion. So something like this, and I'm going to keep doing that in areas where there's discoloration or any areas that I want to adjust the color. And if this view is blurry, you can temporarily turn on your detail layer just to see what you're doing. Now again, make sure you turn off these layers when you're ready to paint back again. I'm going to demonstrate the devastating effect if you don't turn off these layers. If you don't turn off these layers, this is what will happen to the skin here. And that's basically showing the underlying detail of these layers. And that's why it's important to turn these off when you have sample all layers selected. I'm going to undo all that because I don't want this as her skin. And I'm going to turn this off and continue, and see you back here when I'm done. And this is my quick attempt at frequency separation. I'm going to zoom in just to check what we've done here. I'm going to turn off the detailed texture that we applied the adjustment on, so you can see the bumps on her cheeks here. And I'm going to turn it back on to show the effect. And I'm going to turn off the color adjustment layer so you can see the impact of this layer. So turn it off and on. So on this layer, remember, we're adjusting the detail, the texture of the model skin. And here, after the texture has been fixed, we also fixed the color. Now you might say that's just a small area. How about a bigger area? Now, as I mentioned, these techniques are the same regardless of whether the area is big or small. And to demonstrate that, I'll bring up another photo that I retouched. I'm going to press Command or Control O on my keyboard to bring up the Open dialog. I'm just going to open this file here. I've also provided the link to it in the description. I'm going to double click on that to open it. I'm going to fit it to screen by pressing Command 0 on my keyboard. And this is the after photo. I'm going to switch off the adjustments. And this is the before photo. As you can see, the blemishes are quite pronounced on this man's cheeks. And after the frequency separation, I've got this. Now, as I mentioned, my approach to retouching is simply to remove those temporary blemishes. Anything that's more permanent, I would generally leave it alone. I'm just not a big fan of altering a person's characteristics, and I'm not a big fan of the fake plasticky look. So for me, a subtle natural look is what I'm going for. So again, this is the after picture and this is the before. And the great thing about this technique is that it's not only applicable to people, but also landscapes and products and anything where you need to separate the detail from the color. And that's how you can use frequency separation to retouch your images in Photoshop. Now let's review what we've learned so far. We learned that frequency separation is a technique to separate the detail in an image from the color and tones, which is helpful to retouch things like portraits, landscapes, and products. We also learned that frequencies in an image is not this wavy curve that we're used to seeing, but rather the frequencies in an image are the spatial frequencies, and these are represented in black and white shades. And by adjusting the contrast in all the bits in an image, we can recreate any image. And where there are more contrast, that's where the detail in an image is. That's where the high frequencies are. And where there are less contrast, that's where the colors and tones are, the low frequencies. We also fried our brains a little bit by using a little bit of maths to understand the effect that the subtract and add has and how the linear blend modes bring back the high frequency and low frequency layers back to the original image. We also talked about why the settings are different between an 8-bit and a 16-bit image. And finally, we retouched a portrait in a non-destructive way using the mixer brush, clone stamp tool, and used a solar curve to help us see the detailed layer better. And that's how you can retouch your image using frequency separation in Photoshop. In the beginning of the video, I said you'll be the envy of your family and friends with this newfound knowledge of frequency separation. So if you want to continue to level up your Photoshop skills, make sure you check out my other explainer videos on how to mask difficult objects using calculations. The link to that video is in the description.